unfold.
Welcome back to the deep dive. Before we jump right into the material, I want you to just take a second and do a quick silent inventory of your day so far. Did you have a pastry, a splash of something in your coffee, maybe a piece of fruit or a protein bar? Did you eat cereal this morning?
Right.
We're talking about something that is in virtually every single packaged product, every condiment, and, every commercial beverage we consume. We're talking about sugar. It is the inescapable flavor of modern life.
It truly is.
Yeah.
It's ubiquitous. And that sheer volume, the availability of it, that's really the core issue we're digging into today.
Yeah.
We're moving far beyond the usual conversation that frames sugar as, just a simple carbohydrate or a source of empty calories.
Right, a calorie is a calorie.
Exactly. Our mission, based on this incredible stack of sources we have, is to frame refined sugar, so that's sucrose and high fructose corn syrup, as a central, powerful vector in a much larger and, frankly, a far more concerning narrative.
And we have a fascinating, and I have to say, a pretty disturbing set of material here that really forces us to look at this simple white crystal through 4 interconnected lenses.
4 pillars, really.
Yeah, 4 pillars. It's a journey from the very beginnings of its industrial production, through some shocking corporate deception, and finally right into the fundamental biology of our own bodies.
We're tracking its role as a historical engine of atrocity, an example of industrial manipulation, a trigger for neurobiological addiction, and ultimately a source of profound metabolic toxicity.
So our objective today is straightforward. We want to unpack all this evidence and really determine what this substance truly represents in the 21st century.
And the sources are pretty clear on their conclusion.
Yeah.
It must be seen as a ubiquitous preservative, a hyperpalatable additive, and a chronic metabolic toxin.
And understanding this objective is so critical right now because the modern history of sugar consumption, it directly correlates with the global pandemic of metabolic syndrome.
It's a one-to-one mapping, almost. We're talking about the explosion of obesity, type 2 diabetes, heart disease, all the things that define chronic illness in developed nations today.
For so long, the narrative has been that simplistic calories in, calories out model.
Exactly. And that's a narrative that was, often funded by the food industry itself. It implies all calories are equal, and that weight is purely a matter of personal responsibility and energy balance.
Just exercise more.
Right.
Right.
We need to move past that. The evidence we have demands that we explore the specific toxicity profile of the sugar molecule itself.
Okay, so let's unpack this. Before we even get to the biochemical crisis that we're all facing today, we have to respect the historical forces that made this simple commodity the foundation of global power. We have to understand how sugar transformed from this rare, precious luxury into what it is today. A cheap, readily available, exotic necessity.
That phrase is so important.
It really is. So let's start there. Our journey begins in the 17th and 18th centuries. We're far from the modern factory. We're in the incredibly brutal fields of the Caribbean and South America.
Right.
And this first pillar of our analysis is the historical engine that drove the demand for what the plantation owners and traders called white gold.
And it's so crucial we spend time here because the scale of the core perception that we'll get to in part 2, it only makes sense if you understand the unimaginable profits that were established right here in part 1.
Right. The stakes were already sky high.
Exactly. For centuries, dating back to its introduction to Europe, sugar was treated almost like a pharmaceutical. It was a spice, a medicine, a very visible marker of aristocratic status.
A status symbol.
A huge status symbol. If you could afford sugar, you were signaling immense wealth and power to everyone around you.
But the sources, they cite the anthropologist Sidney Mintz, who tracked the exact moment this status symbol became a staple for everyone.
Yes, and he described the process as the creation of a mass-produced exotic necessity. To achieve that, you had to completely reorganize the entire global economy. You had to industrialize the growing, the harvesting, and the processing of sugarcane.
And that economic reorganization was fueled entirely by the labor of enslaved people.
100%. The key discovery was that the tropical climate of the New World, the Caribbean, Brazil, parts of the American South, it was absolutely perfect for growing sugarcane.
And that unlocked a profit potential unlike anything Europe had ever seen before.
It did. The problem was the sheer, back-breaking, brutal labor required to capitalize on it.
We often simplify the economics of this into the triangle trait, but your material really emphasizes that this system was a sophisticated global engine of commerce. The sources describe it as being as round as the globe.
Yeah, that's a great quote.
So what specific components made this economic structure so powerful, so efficient, and at the same time, so devastatingly cruel?
Well, it was a perfectly integrated system, designed for one thing: maximizing commodity flow. This wasn't just, a few ships sailing between three ports. It was much bigger.
Okay.
You had the textile mills of England and Europe manufacturing cheap goods. Those goods were necessary for trade in West Africa, where they were exchanged for human chattel.
So the first leg is manufactured goods for human lives.
Exactly. Then those enslaved people were shipped across the Middle Passage to the plantations in the Americas. And the resulting product, the sugar, the rum, the molasses, was then shipped back to Europe, financing the entire cycle all over again.
And the profits from sugar, they weren't marginal, they were monumental.
Oh, absolutely. They didn't just fund more trade, they fueled a massive cultural and economic shift back in Europe.
How so?
Well, think about the Industrial Revolution sweeping across Britain and Western Europe at the time. As populations moved from farms into these punishing factory shifts, they needed dense, cheap, and immediately available calories just to survive the grueling labor.
And sugar was the answer.
Sugar was the answer. It came through sweetened tea, cheap coffee, and eventually jams and pastries. The sources call sugar the drug food of the 19th century.
The drug food.
Yes, a chief addictive calorie source that sustained the working poor while it was simultaneously financing Western empires, especially the expansion of the British Empire.
So we have this massive integrated global demand driving everything, but the actual production process on the plantation was, as you said, uniquely difficult, which just exacerbated the cruelty of the whole system.
It did.
Sugarcane isn't like other cash crops, is it?
No, not at all. And that biological reality is really the key to understanding the architecture of the plantation. Sugarcane, once it's cut, it has to be processed incredibly quickly.
Why is that?
It starts to ferment and spoil within about 24 hours.
Yeah.
So that biological constraint meant the processing facilities, the mill for crushing the cane, and the boiling house, they had to be on-site and operational immediately.
Which created this specific horror of the plantation as a kind of 24-hour agro-industrial factory.
Yes. The speed of processing became the sole determinant of profit. And that made the labor schedule just relentless during what they called crop time.
And the overseers pushed the enslaved workers to their absolute limit. The labor was divided into these incredibly specialized, incredibly dangerous tasks.
Right. You had the field gangs cutting the cane under the merciless tropical sun. But the real industrial dangers, the true horrors, were inside the mill and the boiling house.
I want to focus on the mill operation for a moment because the detail provided by the sources about the mill workers is just chilling.
The mill was where the cane was crushed to extract the juice. The workers known as feeders were responsible for pushing the cane stalks into these vertical, heavy stone or steel rollers.
And it was repetitive, monotonous work.
Incredibly monotonous and done under conditions of profound, unimaginable exhaustion.
And this exhaustion, combined with the continuous operation of the machine, it led to devastating accidents.
Frequently. Hands or fingers would inevitably get caught and pulled into the rollers. And this is where you see the brutal detail that speaks volumes about the priorities of the system.
Okay.
Plantations didn't just have first aid nearby. They frequently kept a heavy, sharp hatchet nearby.
Not to save the worker.
No.
But to save the schedule.
To save the schedule and the machine. The hatchet was there to immediately sever the limb, the finger, the hand, the arm of the worker who was caught.
Wow.
This was done to prevent their entire body from being pulled into the crushing rollers, because that would not only kill the person, but it would also break the very expensive, crucial machinery and stop the entire production line.
That single detail, it just encapsulates the entire system's calculus. The value of the machine and the production schedule outweighed the value of an enslaved person's intact body.
That's the blueprint right there.
Yeah.
And the boiling house was no less horrific. Workers known as boilers managed a series of copper kettles filled with this scalding, sticky liquid, transferring the thickening syrup from one stage to the next.
So they were essentially working inside an oven.
Under tropical conditions, yes. The sources note that temperature often exceeded 100 degrees Fahrenheit, that's 38 degrees Celsius, often with terrible ventilation. The risk of severe, life-altering burns from splashing boiling syrup was constant.
And these were skilled laborers.
Highly skilled. They were absolutely central to the plantation's profit, yet they were subjected to the most extreme physical and environmental stress imaginable.
So when you combine the physical toll of the field labor with the industrial danger of the mill and the boiling house, the human cost of producing this white gold was just catastrophic.
It was.
The material stresses that the enslaved populations, they simply could not sustain themselves.
The sources confirm this. It's a demographic reality. Because of the poor nutrition, the relentless physical demands, and disease, the enslaved population in the Caribbean was what one source calls a demographic black hole.
A black hole, what does that mean exactly?
It means they could not sustain themselves through natural birth rates. The death rate was so high it required a continuous, brutal influx of captives from Africa just to keep the numbers stable.
And this brings us to that chilling economic calculus we mentioned, the decision to work people to death rather than sustain them.
It was an economic calculation unique to the most brutal commodity industries. It was often deemed more profitable, especially in the Caribbean and Brazil, to work an enslaved person to death within a few short years and simply purchase a replacement from a newly arrived slave ship.
Rather than invest in the housing, nutrition, and rest required to keep them alive for decades.
Exactly. They were literally seen as disposable industrial components.
What are the specific statistics cited in the material that truly illustrate this catastrophic human cost? I mean, the scale of it is hard to grasp.
The numbers are just staggering, and we have to absorb them. The average life expectancy for an enslaved African upon arrival at a sugar plantation was, in many documented cases, as low as 7 years.
7 years.
Just 7 years. In the 18th century British Caribbean, the mortality rates were so immense that the enslaved population decreased by 3 to 4% annually. That deficit was only filled by the relentless, continuous arrival of more slave ships.
And that only accounts for those who actually arrived and started working.
Right. We have to account for the loss of life during the journey itself, the Middle Passage.
Which was horrific in its own right.
If you track the journey from the very beginning, the moment of capture in the African interior, the loss is compounded. Of every 100 people seized, it is estimated that only 48 survived.
Less than half.
Less than half survived the march to the coast, the subsequent ocean voyage, which claimed 10 to 15% of its passengers, and then arrived in the Americas alive to begin labor.
That immense loss of life, that human carnage, was the hidden input cost of the sugar consumed in European tea parlors and factories.
It was.
So the takeaway from this first pillar is just profound. Every pound of sugar we consume is historically linked to a system that established the prototype for the modern industrial food complex.
A system that inherently prioritizes profit and efficiency over human dignity and life itself. It established the foundation of obscuring ethical costs from the consumer.
And that principle, that idea of manipulating reality for profit, is precisely the theme we see replicated when the threat shifted from abolitionists to scientists in the 20th century.
Yes, exactly.
Let's transition now from that 18th century economic structure to the 20th century corporate strategy. By the 1950s, the threat to the sugar industry wasn't abolition. It was the rising death toll from coronary heart disease.
The CHD epidemic in the U.S.
Right. People were dropping dead from heart attacks at an alarming rate, and scientists began pointing fingers at the American diet.
And this health crisis, it created a scientific crossroads. There were two powerful competing theories about the dietary cause of CHD.
Okay, what were they?
On one side, you had 𝐏𝐻𝐃𝐂𝐂𝐓, who was championing the hypothesis that saturated fat and dietary cholesterol were the villains. On the other, you had the British physiologist John 𝐏𝐻𝐃𝐂𝐓, whose research was increasingly implicating sucrose sugar.
And the industry, specifically the Sugar Research Foundation, or the SRF, which was the precursor to the Modern Sugar Association.
They recognized immediately that this was an existential threat. If 𝐏𝐻𝐃𝐂𝐓 won that debate, their entire market could collapse.
So they didn't just sit back and hope for the best.
Not at all. The internal documents that finally came to light in 2016, they confirmed that the industry launched a sophisticated, decades-long campaign of manipulation to control the scientific discourse. This was a preemptive, aggressive, strategic pivot.
And the source material pinpoints the strategic thinking all the way back to a 1954 calculation by the SRF president, a man named Henry Haas. And this really reveals the cynical brilliance of their plan.
Haas identified a huge opportunity hidden within the fat debate. He calculated that if the SRF could successfully push the emerging low-fat health message, so persuade Americans to reduce their fat intake to, say, 20% of total calories.
Then those calories would have to be replaced by something else.
Exactly. They would be recaptured by the carbohydrate industries. And if sugar merely maintained its existing market share within those displaced carbohydrates, per capita sugar consumption would increase by more than a third.
Wait, I need to slow that down for a moment because that's huge.
It is.
The entire public health movement, the low-fat messaging that defined the 70s, the 80s, the 90s, forcing us all towards low-fat yogurt, low-fat cereals, low-fat snacks.
All of it.
That was, for the sugar industry, an explicit strategic marketing ploy designed to increase their own product sales by over 33%.
It was a phenomenal generation-spanning strategic deception. It was a masterstroke of deflection, shifting the public's attention entirely onto fat.
But to fully execute that plan, they had to eliminate the competing hypothesis.
They had to silence John Yudkin.
Right, and by the early 1960s, his lab was producing solid data showing that high-sugar diets not only contributed to weight gain, but specifically elevated serum cholesterol and triglycerides. He was a real threat.
A huge threat. So the SRF vice president, John Hickson, targeted Yudkin directly. And Hickson's recommendation, detailed in the memos, was crystal clear.
What was his instruction?
He said the SRF should fund a literature review, not to search for the truth, but specifically to refute our detractors. The goal was to commission a paper that would systematically pick apart any anti-sugar research, while simultaneously using this scientific platform to bolster the anti-fat, anti-cholesterol narrative.
And this brings us to the operational reality of the conspiracy, Project 226, which was commissioned in July 1965. And this wasn't just some junk study they funded. They targeted the absolute pinnacle of academic credibility.
They did. They approached 3 influential researchers at the Harvard School of Public Health, Dr. Robert McGandy, Dr. Mark Hexted, and the powerful department chair, Dr. Frederick Stare.
And what was the price for this?
The transaction price was reported at $6,500, which I know it seems small today, but it was a significant sum back then. About $49,000 in 2016 terms.
A pretty cheap way to buy decades of scientific consensus.
Incredibly cheap.
But what's truly disturbing, and where the sources reveal the true conspiracy, is the level of direct control the Sugar Research Foundation had over these Harvard researchers.
There wasn't an independent grant.
No, it was editorial oversight.
The control was explicit, and it's documented in multiple internal correspondences. First, John Hickson dictated the scope of the review. He supplied the Harvard team with the articles they were to review.
So he curated the evidence.
He curated the evidence to exclude or minimize anything unfavorable to sugar. The data was rigged from the start.
And what's the second detail?
The second and most damning detail is that the researchers were required to submit their drafts directly to the SRF for review and approval before sending them to the journal for publication.
Unbelievable.
Hickson even confirmed in a memo that the final draft was quite what we had in mind, and we look forward to its appearance in print. The conclusion was determined before the research even began.
So they bought the highest academic stamp of approval available. And the result was this 2-part review published in the New England Journal of Medicine in 1967.
And that publication carried monumental weight. It essentially told the entire medical and public health community that the science was settled.
The debate was over.
The debate was over. The only dietary intervention needed to prevent CHD was reducing fat and cholesterol. It systematically dismissed all data linking sugar to heart disease as anecdotal or preliminary.
And the crucial missing piece, the ethical violation that allowed this deception to be sustained for so long?
The industry funding and the explicit terms of control were never disclosed in the NEJM publication. That lack of transparency allowed the review to shape global policy for decades, cementing the low-fat dogma and completely silencing the competing sugar hypothesis.
So if Project 226 was the industry's great success, the fate of John Yudkin was the devastating consequence.
It was.
He warned us clearly in the early 70s.
His 1972 book, Pure, White, and Deadly, was unequivocal. He stated that sugar was not just a calorie source, but the primary driver of heart disease and diabetes. He was shouting into a void manufactured by industry funding.
And how exactly did they manage to destroy the credibility of a scientist of his stature?
The industry, through various proxies, launched this massive campaign of ridicule and marginalization. The UK industry group, the Sugar Bureau, dismissed his claims as sensationalist and emotional.
And other academics piled on.
Key academic figures, most notably Ansel Keys, whose own career benefited immensely from the anti-fat consensus, publicly attacked Yudkin's work as shoddy and a mountain of nonsense.
That must have been just devastating for him professionally.
It was career-ending. Yudkin was ostracized by the nutrition establishment. He was denied funding. He was uninvited from major international conferences, and his ideas were dismissed as quackery. He died, marginalized, in 1995.
And it was only with the uncovering of the SRF documents in the mid-2010s that his work was finally fully vindicated.
Decades too late.
So we spent 50 years, a minimum of 2 generations, fighting the wrong dietary battle because of one successful, documented $6,500 conspiracy.
It's staggering when you put it like that.
The public policy implication is just huge.
Yeah.
Think of all the low-fat, high-sugar, high-carb products that became ubiquitous in the 80s and 90s. The explosion of breakfast cereals, fat-free dressings, sugary snacks. That was the direct result of this engineered consensus.
And the chronic disease epidemic we see today is the debt we are paying for that deception. And that manipulation, it didn't stop in academia. It evolved into engineering the product itself.
Which brings us to the science of the Bliss Point.
Yeah.
And I'm thinking less about nutritionists here and more about chemical engineers.
You're right. The food industry began marrying chemistry with psychological modeling. The Bliss Point, which was pioneered by food scientists like 𝐏𝐻𝐃𝐂𝐓, is the mathematically precise concentration of sugar, along with fat and salt, that maximizes sensory pleasure without becoming cloying.
So the goal is to maximize the palatability curve to the exact sensory peak.
Exactly. I remember reading about Moskowitz's work with products like Dr. Pepper. It's not just about tasting good, it's about tasting optimal.
Right.
They use mathematical modeling to determine the exact level of sugar that ensures the consumer's brain is fully engaged, but their satiety signals, the signals that tell you you're full, are overridden.
Investigative journalist Michael Moss describes this as a conscious effort to create hyperpalatable foods that drive repeated consumption.
It's engineering for overconsumption. And when critics push back on the obesity crisis, the industry just falls back on its decades-old defense.
The energy balance model. All calories are created equal.
It's a convenient deflection that blames the victim. It frames the problem of obesity and chronic disease as a failure of personal responsibility. You just need to exercise more or eat less.
And that completely obscures the specific, unique metabolic toxicity of the fructose component of sugar and the addictive environment the industry specifically engineered.
It allows them to position these highly processed, sugary foods as part of a balanced lifestyle, conveniently ignoring the biochemical reality we're about to explore.
Okay, so we've established a history in the conspiracy. Now we have to ask the fundamental question. If we know sugar is toxic, why can't we just stop eating it?
Right.
Does sugar truly hijack the brain in a way that aligns with genuine substance abuse?
The neurobiological evidence is now substantial enough to dismiss the industry's polite terms like craveability or allure.
So this is more than just liking sweet things.
Much more. The observed behavioral patterns in both human and animal models, we're talking binging, withdrawal symptoms, the need for increasing amounts, they align strikingly well with the established criteria for substance use disorders defined in the DSM-5.
So it's recruiting the exact same neural pathways as narcotics.
It is. Okay, so let's slow down and define this mechanism clearly for the listener. Let's start with the central engine of addiction, the dopamine reward pathway.
Okay.
This is the mesolimbic dopamine system. You can think of it as the brain's GPS for survival and pleasure. It runs from an area called the VTA to the nucleus accumbens, or the ENaC.
The reward center.
The reward center, exactly. Yeah. This system evolved to powerfully reinforce behaviors that are essential for our survival, like eating nutrient-dense food, reproducing, and safety. Dopamine is that chemical signal that says, do that again, that was good for survival.
So how does refined sugar manage to differentiate itself from natural food in this crucial system? An apple has sugar, but it doesn't feel like a drug.
That's a great question. If you eat a food found in nature, like that apple, it causes a moderate regulated dopamine release. Your brain registers satisfaction, you feel full, and you typically stop.
Right.
Refined sugar, though, especially when it's combined with fat and salt at that bliss point, delivers what the sources call a supraphysiological blast.
A blast.
It's an immediate, excessive, and unnaturally large reward signal. It completely short-circuits the natural regulatory feedback loops in the brain.
And chronic overstimulation of that system is the textbook path to addiction, regardless of the substance, isn't it?
That's the key. Studies show that when subjects have intermittent high-dose access to sugar, the dopamine release is so excessive that the brain basically views it as too much noise. To protect itself, the brain begins to turn down the volume.
How does it do that?
It does that by removing or reducing the number of dopamine receptors, specifically the D2 receptors, on the surface of the neurons.
So the system gets dull, which results in what's called reward deficiency.
Exactly. The individual now needs increasing amounts of the substance, a higher dose of sugar, just to achieve the baseline level of pleasure or satisfaction they felt previously.
And that requirement for an increasing dose simply to feel normal?
Is the clinical definition of tolerance, and it sets up a powerful physiological dependency loop.
And the evidence that sugar's reward system is just overwhelmingly potent is best demonstrated in those incredible comparative studies between sugar and hard drugs. I mean, I had to read this section of the material twice to really believe it.
This is the hard, cold biological proof against the idea that sugar is just nice or a simple indulgence. Researchers performed a landmark study where they gave laboratory rats a clear choice.
Okay.
They could press a lever for intravenous cocaine, or they could press a different lever for sweetened water, either sucrose or a saccharin substitute.
And what happened? What percentage chose the chemically potent narcotic?
The results were just definitive. 94% of the rats preferred the sweet taste over the cocaine.
94%.
Yes. This wasn't a slight majority. It was an overwhelming preference. I mean, think about the pharmacological power of cocaine, one of the most addictive, immediately rewarding substances known to man.
The drive for sweetness just surpassed it.
It surpassed it. And I have to push back on the idea that this preference is somehow fragile. The material emphasizes the resilience of this preference. It persisted even when the researchers tried to sensitize the rats to cocaine, meaning they were biologically primed for the drug's effects.
So even when they were already hooked on cocaine, they still chose the sugar.
They still chose the sugar. It persisted even when the cost of the sugar, measured by the number of lever presses required, was dramatically increased. The intense sensory reward of sweetness, according to the researchers, surpassed maximal cocaine stimulation.
That makes the whole discussion of personal responsibility incredibly difficult, doesn't it? We are fighting a biological imperative that evolved to save us but is now being leveraged against us by industrial food science.
And sugar's grip is dual-pronged. It engages not just the dopamine system, but also the endogenous opioid system.
Our internal pain and comfort mechanism.
Like internal morphine. The connection to comfort food makes perfect sense here.
It does.
Sugar consumption triggers the release of opioids within the body, like enkephalins and beta endorphins. This release provides feelings of analgesia, pleasure, and comfort. The effect is so powerful that concentrated sugar solutions are routinely given to newborns in hospitals to reduce the pain they feel during minor procedures, like heel pricks.
So if sugar activates our internal opioid system, then someone attempting to quit should experience symptoms that look suspiciously like opioid withdrawal.
And that's exactly the biological proof of physical dependence. The clearest demonstration is through a process called precipitated withdrawal.
What's that?
Researchers administered naloxone, which is the powerful opioid antagonist used to reverse overdoses from substances like heroin to rats that were habituated to a high-sugar diet.
And naloxone, which blocks those opioid receptors, would immediately trigger withdrawal symptoms if the animal was physically dependent.
Correct. And the rats exhibited classic opiate withdrawal signs: teeth chattering, visible paw tremors, head shakes, and markedly elevated anxiety levels.
So this confirms that the body develops a genuine physical dependence on the endogenous opioids released by sugar consumption. It's not just a mental fixation, it's a physical cycle.
It is. And for humans trying to quit, this manifests as the notorious sugar flu. The sources provide a very useful timeline for what you can expect when you start a sugar-free period.
Let's walk through that. What's the first phase?
The human withdrawal process typically follows 3 intense phases. Phase 1, days 1 through 5, is the acute physical phase. This is when your body is metabolically clearing the substance and adjusting to the lack of its usual fuel source.
And the symptoms?
They are flu-like: intense headaches, profound, often debilitating fatigue, nausea, and muscle aches.
Then the physical pain subsides and the psychological battle begins.
That's phase 2, usually days 5 through 14. The acute physical symptoms start to lessen, but the psychological ones peak. This is the hardest phase for many people.
What happens here?
Extreme irritability, intense anxiety, mood swings, and severe intrusive cravings. This reflects that deep dopamine deficit state we talked about. The D2 receptors are slowly upregulating, but the brain feels starved of its expected reward.
That 2-week window is where most people relapse because the psychological discomfort is just so high.
It's the moment of truth. Finally, in phase 3, from weeks 2 to 4, the cravings generally start to diminish in intensity. A full recalibration of the reward system and your taste buds takes about a month.
And people report that foods they used to think were bland now taste intensely sweet.
Exactly. But that initial 2 weeks is a true period of physiological and psychological detox.
Now, I find this next point perhaps the most disturbing of the entire deep dive. The material suggests that this vulnerability, this neurological scar, might not just affect the individual, it may be passed down.
We're talking about intergenerational epigenetic effects.
Right, and this is a profound and relatively new area of study.
Epigenetics, simply put, is how your diet, environment, or stress can turn certain genes on or off without actually changing the underlying DNA sequence.
Okay.
And studies have shown that paternal sucrose consumption, so the father's diet before conception, can specifically alter gene expression in the sperm, which then impacts the offspring.
So it's not just about what the mother ate during pregnancy. The father is effectively transmitting his metabolic and neurological history.
The findings are disturbing. Even without their own exposure to a high-sugar diet, the offspring of sugar-fed fathers exhibited higher baseline anxiety levels, altered brain structure in their reward pathways, and greater reward-seeking behavior.
Wow. This means the metabolic and neurological scars of sugar consumption may be heritable.
Yes.
We aren't just making a personal choice. We are potentially predisposing future generations to both metabolic disease and addictive behaviors before they ever take their first bite.
It completely reframes the discussion of individual choice into one of ancestral vulnerability.
It forces us to ask, if high sugar intake physically alters the operating system of the next generation's brain, how can we possibly expect them to navigate this hyper-palatable, sugar-drenched food environment we live in?
That's the question.
Okay, that sets the stage for our final pillar, the metabolic catastrophe. We've established the history, the corporate manipulation that keeps consumption high, and the addiction cycle that makes it so difficult to stop. Now we address the core lie perpetuated for decades, that a calorie is a calorie.
This myth, which underpins the industry's entire energy balance defense, has been thoroughly dismantled by modern endocrinology and biochemistry.
And the key insight, championed by experts like Dr. Robert Lustig, is that the source of the calorie dictates its metabolic fate.
That's it. And the fructose component of sugar has a uniquely toxic profile that glucose does not share.
Let's break down the chemistry of table sugar, or sucrose, and high fructose corn syrup. They're both essentially a 50-50 split between glucose and fructose.
Right.
They have the same caloric content, but the body treats those two molecules completely differently.
Absolutely. You can think of it as two different types of fuel. Glucose is the molecule of life. It is the primary universal energy source for every cell in your body, your brain, your muscles, your organs.
Okay.
When you consume glucose, roughly 80% of it is utilized immediately by peripheral tissues, and its metabolism is tightly controlled by the hormone insulin. Insulin is like the traffic cop that tells the body, energy has arrived, use it or store it safely.
And then you have fructose.
Fructose is the molecule of flavor. It is non-essential, meaning there is no known biochemical reaction in the human body that requires dietary fructose. And crucially, it bypasses the body's primary traffic control mechanisms.
Unlike glucose.
Right. Unlike glucose, fructose is metabolized almost exclusively by the liver.
And critically, it doesn't stimulate insulin directly, which is a big problem for the brain's satiety signals.
It's a complete failure of the satiety signal. Because it doesn't stimulate insulin effectively, the brain doesn't get the proper signal that calories have actually been consumed. Furthermore, it doesn't effectively suppress ghrelin, the hunger hormone.
So you can drink hundreds of fructose calories, particularly in liquid form like soda.
And metabolically, you remain hungry. It's a mechanism that is almost designed to promote overconsumption.
And this brings us to Dr. Lustig's famous and now academically supported characterization. Fructose is alcohol without the buzz.
Yes.
The sources confirm this isn't just a catchy phrase, it's a statement of biochemical fact.
It is a biochemical reality because both ethanol alcohol and fructose share the exact same pathway in the liver. They are both preferentially processed by the liver, and they serve as primary substrates for a process called de novo lipogenesis, or DNL.
Which is the creation of new fat.
The creation of new fat from scratch.
Can you walk us through that DNL process, maybe use an analogy rather than listing the chemical pathways, to show what happens inside the liver when it's hit by a massive dose of fructose, like from a soda?
Of course. Think of the liver as a bustling industrial city, and the mitochondria are its power plants, designed to burn fuel efficiently. When you consume a natural amount of sugar from a whole food, The power plants can handle it.
No problem.
But when you flood the liver with a massive refined bolus of fructose, like from a 20-ounce soda, you've essentially overwhelmed the city's infrastructure. The power plants, the mitochondria, they cannot process the energy fast enough. They are flooded.
And the machinery gets backed up.
It gets backed up, and the liver's only immediate choice for clearing this massive excess energy is to convert it almost immediately into fat, specifically triglycerides. That DNL process is a survival mechanism, but when it's constantly overloaded, it causes profound pathology.
And this is exactly what happens with heavy alcohol consumption, just without the neurological effect.
Precisely. The end result of both ethanol metabolism and fructose metabolism is an excessive creation of fat molecules within the liver cell itself. The fructose pathway leads quickly to the accumulation of liver fat, which induces hepatic inflammation, metabolic damage, and ultimately insulin resistance.
And the systemic result of this is that paradoxical state of metabolic starvation.
That's the consequence. The fat accumulation in the liver induces resistance to the hormone insulin. So the pancreas tries to compensate by pumping out huge amounts of insulin, a state called hyperinsulinemia.
So insulin levels are constantly high.
Chronically high. And this high insulin acts as a massive signal across the body, forcing energy storage into fat cells everywhere. You become simultaneously obese, yet your cells are metabolically starved of the energy they need because they can't efficiently access or utilize the fuel anymore.
So you're locked in a continuous cycle of hunger and weight gain.
Exactly.
And the most tragic and rapid manifestation of this unique toxicity is the rise of pediatric non-alcoholic fatty liver disease, or NAFLD, in children.
This is arguably the most damning indictment of the current food environment. Historically, severe fatty liver disease was a signature disease of middle-aged heavy alcoholics.
Right.
Today, it is the most common liver disease in the pediatric population. The source's estimated affects around 13% of all children and up to 50% of children who are classified as obese.
The sources use the analogy of human foie gras. That is a brutal analogy, but it makes the point perfectly clear.
It's an unavoidable analogy. Just as geese are force-fed carbohydrate-rich compounds to intentionally and rapidly fatten their livers for the delicacy, children consuming these high-fructose, hyper-palatable diets are developing fatty livers at alarming rates.
And when a liver becomes fatty, it becomes inflamed, it hardens, and it struggles to perform its vital detoxification functions.
And this pathology directly leads to higher risks of diabetes and cardiovascular disease down the line.
The clinical data supporting this link is now irrefutable, and the key intervention study cited in the sources provides what feels like the definitive smoking gun.
This is the study that definitively separates the calorie argument from the toxicity argument. Researchers took obese children who were already diagnosed with NAFLD, and they put them on a sugar-restricted diet.
Okay.
But critically, the total calories were kept constant. Sugar was simply replaced with starch.
So they weren't losing weight, but they were removing the fructose.
Exactly. And in just 8 weeks on this sugar-restricted calorie-matched diet, the children's liver fat decreased significantly by over 20% on average, and their insulin sensitivity improved markedly.
That rapid turnaround, keeping total calories the same, proves unequivocally that the sugar molecule itself drives the pathology, independent of general weight loss or caloric restriction.
That's a powerful validation of the fructose as toxin argument. It is the scientific rejection of the industry's entire defense. The molecule matters.
So moving from the biochemical reality to the consumer reality, the final practical barrier for anyone trying to take control of their health is the systematic industrial obfuscation of sugar on food labels. It's nearly impossible to track your consumption.
This is their final layer of defense: ingredient splitting. Since mandatory labeling requires ingredients to be listed by weight, manufacturers deliberately use at least 56 different names for sugar.
56.
At least. This ensures that sugar never appears as the first ingredient on the label, which might alert a health-conscious consumer.
56 aliases? I mean, who can possibly keep track of that? It's designed to confuse.
It is absolutely designed to mislead. Let's highlight some of the categories the sources point out. Look for the syrups and nectars. Everyone knows high fructose corn syrup is bad, but look out for brown rice syrup, which is heavily processed, or agave nectar.
Agave is often marketed as natural.
Right, it's seen as natural, but it can be concentrated to up to 90% fructose, which makes it potentially worse than table sugar in terms of activating DNL in the liver.
And the category I find most frustrating is the so-called healthy sugars, the ones that leverage a health halo to trick consumers into thinking they're making a great choice.
Yes, things like coconut sugar, date sugar, honey, or turbinado sugar. The sources clarify that while these may be slightly less refined or retain some trace minerals, biochemically, they are still complex mixtures of sucrose and fructose.
They drive insulin resistance and DNL just as effectively as plain white sugar.
Exactly, despite their perceived natural marketing status. And then you have the endless chemical names: dextrose, maltodextrin, crystalline fructose. It's a shell game. You could look at a breakfast bar, see 5 different names for sugar, and completely underestimate your total intake.
The strategy is deliberate. It exploits the consumer's desire to make healthier choices. By labeling something organic cane juice crystals instead of just sugar, the manufacturer can maintain that hyperpalatability while making the consumer feel virtuous.
And the result is the continued consumption of the exact same toxic substrate.
It truly seems the industry is determined to maintain its profits regardless of the cost, whether that cost was measured in human lives in the 18th century or metabolic disease today.
So if we synthesize everything we've covered, the categorization of sugar as the sweetest poison is not a hyperbolic statement.
Oh.
It is a conclusion demanded by the convergence of history, industry documents, and molecular biology.
So we've established that sugar is a historical agent of atrocity, founded on the industrialization of slavery that prioritized profit over human dignity, setting the stage for all future deception.
It is a documented engine of corporate conspiracy. Through Project 226, the industry successfully manufactured scientific doubt, shifting the entire public health dialogue onto fat, thereby delaying effective policy intervention by over 40 years.
Which directly fueled the current obesity and diabetes pandemic.
Absolutely. And biologically, it's a neurochemical hijacker, engaging reward pathways with a potency that rivals cocaine, creating an addiction cycle that makes moderation physiologically impossible for large segments of the population.
And finally, it's a potent hepatotoxin. It overloads the liver's capacity, driving de novo lipogenesis, profound insulin resistance, and the tragic modern epidemic of pediatric fatty liver disease.
If we connect all this to the bigger picture, the crisis we face today stems directly from that successful industry deflection of blame. We've spent the last 4 decades fighting the wrong dietary villain,
consuming vast quantities of high-sugar, low-fat products that actively sabotage our metabolic health.
The paradigm shift that's required must move beyond the simple calorie model. We have to collectively recognize sugar as an addictive, industrially engineered additive with a distinct, documented toxicity profile that requires public health intervention.
And until public policy is enacted that truly reflects this biochemical reality and that actively challenges the industry's sophisticated lobbying power and the misleading personal responsibility narrative, the metabolic crisis will just continue to consume the health and resources of the global population. The debt keeps growing.
And that leaves us with a final provocative thought to mull over, one that builds on our discussion of intergenerational effects.
Right.
We learned that the neurological and metabolic scars of high sugar consumption may be heritable, with epigenetic changes passed from father to child, potentially predisposing the next generation to both metabolic disease and anxiety.
So consider how understanding this generational transmission changes the way we view our responsibility. It's not just to our own health, but to the metabolic future of the entire population.
What further research is needed, and how can we accurately quantify the true societal cost in health, in resources, and lifespan that resulted from the deception of Project 226 today? That is the real debt we are all still paying off.